Welcome to the lecture on classification of joining processes. So far in the course we have discussed about two of the manufacturing process, that is casting and forming. Now we will discuss about the another important manufacturing process, that is known as welding or joining process. So joining is a broad term and welding is one of the joining technique. So broadly we will discuss about the classification of joining processes. In that, welding will come, and typically we will discuss about different types of welding processes. So coming to the need for the welding process or joining process, it is necessitated in many situations when you cannot cast or form a component of certain shape. So suppose it has a very small component joint and which cannot be otherwise designed to be formed by casting or forming, or sometimes something breaks and you need to further use it. So in that case, how can you further use it? Either you replace it, or the only remedy is that if it can be used by joining the two pieces which has been broken off, either during handling or during the operation. So this way you need to join it. So unlike the manufacturing processes employed to produce a single component, the joining processes are used to assemble different members to yield the desired complex configuration. So that is what is the need for the welding process or joining process. Now when we talk about the joining of components, now that joining of components may be either temporary or permanent in nature. So temporary means that they can be taken apart further, they can be separated without losing the identity of the two parts which is added. And then the other is permanent. So in the permanent case, when you are trying to separate them out, then certainly there will be damage to the parts. So that way its identity is in question. There will be certain modification in the characteristics of the two parts which you are joining. So that is what the difference between the temporary and permanent type of joining. Another category is there, and that is the semi-permanent type of joining. So in the semi-permanent type of joining, basically you don't have that choice to restore the mechanism by which you join. Although the parent material which you are joining, they will be intact, they will be okay, but then other things you are not that way further restoring completely that way. So that is there is a damage to that part. So suppose like you take the example of nut bolt. If you join the two parts with nut and bolt, that is something like very temporary, because whenever you want, you take the nut and bolt out, and the two sheets which are joined, they can be again apart, so they can further be joined whenever you need. Similarly, if you do by arc welding, so that is joining by nut bolt is a type of temporary type of joint. Then if you join it using the welding process, fusion welding process typically, where you are making the plates mate each other, and then you are heating at the junction point, and then you are converting it into liquid state so that they are solidifying and being one unit. So that type of joint is a permanent joint, and whenever you have to take the plate out, you will have to break it. So while breaking, there may be damage to the sheets, because it is like a metallurgical bonding, so it will be like a single piece, so you have to cut it or whatever. But if you do some bondings like braze welding or soldering, in that case you can just heat little bit and take the sheets out. Certainly the braze or solder will be removed, so you have to further use that for further joining. So that is of semi-permanent type, where the plate is all right, but the solder which was there, anyway, that is again if you have to add it, you have to further use that solder material, or you have to use the process again. So, this way you have this either temporary type of joining or semi permanent type of joining or permanent type of joining that is in nature. Again, mechanism of bonding may be either mechanical bonding or atomic bonding. So, as we discussed, we can use it the mechanical means and then see that they are bond to each other, or there may be bonding at the atomic level. So, there is diffusion of atom, or atoms are there, they solidify, there is a bonding between atoms, and that way the strength develops. So, it may be either mechanical bonding or atomic bonding. Another criteria which is used for classifying the joining process is based on the composition of joint. So, on that basis you are classifying that process on the basis of that composition of joint, that is autogenous, homogeneous and heterogeneous. So, what is autogenous type of welding? So, in autogenous type of welding you do not use any filler material. So, during that joining, so no need of any filler material. So, all type of solid phase welding and resistance welding, they are under that. So, basically you have two pieces and somehow you do not use any external filler material to add. So, you must be knowing, you must have the idea about the filler materials, parent material in welding. So, in the case of autogenous you do not use these filler material during that joining. Then you have homogeneous. Now, in the homogeneous, the filler material which is used for joining the two parent material having two sections. So, they are having the same composition as the parent material. So, when you are joining two plates, in that case, so whenever we do the welding, so what we do is you have two plates and then we try to weld it like this. So, these are the these are the parent materials, and this is the weld pool normally that you must have studied so far. So, this is the pool where the fusion takes place or the binding takes place in the case of fusion welding. Now, the thing is that this material, it may be having the composition same as parent material, or it may have the different kind of composition as compared to the parent material. So, suppose if this is steel and this is also having the similar composition that of steel, in that case it is known as homogeneous type of welding. So, the example of this is normally arc, gas or thermit welding. Now, in the case of arc welding, you produce arc and they try to melt here. So, parent material as well as a filler material will be melted and then they will form this weld pool. So, if and in typical case, in normal case, in the case of arc welding or gas welding or even thermit welding or so, you try to see that the composition of the liquid metal which you get by melting the filler material, it is similar to that of the parent material. In that case, it is an example of homogeneous material, homogeneous welding. Then you have another classification, another variety is the heterogeneous type of welding. Now, in the case of heterogeneous welding, you have the filler material which is different from parent material. So, what we have now in the case of heterogeneous, the composition of this and this is different than this. So, the filler material which is used for joining the two parts, that is different than the parent material which is added, so which is joined. Now, in that case, it will have different composition, it has the different properties. So, the example is soldering and brazing. So in the case of soldering and brazing, this is either solder material or this is either the braze alloys which we use. You have in the solder you have tin lead alloys, or in the braze you have silver based alloys are used. So and you have copper and all that is used in the case of brazing. So in that you have this as the different property than this, and in the case of homogeneous is since these having the same compositions, their property will be similar, their property will be same. So, it is like a uniform property material, whereas in this case the property will not be uniform, this will have the same property, but this property may be inferior. So, it is basically used for specific purposes where you are just working for the sake of holding its shape. So, in the soldering case the temperature is solder alloys melting temperature is even less. So, there the strength is even less, but then they are normally, that is a requirement. Suppose mostly whenever you go for the electronic areas like printed circuit board or so, in that case of joining you go for soldering, because you cannot you have just to add them, just to join them. So, strength is not the criteria. And in brazing certainly that is a little bit more. So, you have the braze alloys, and here basically they are differentiated based on the temperature. So, that we will discuss when we discuss about the soldering and brazing later on. So, that is your this classification, that is autogeneous, homogeneous and heterogeneous. Now, coming to the subcategories and you have examples. So, now we come to mechanical bonding, and we talked about the mechanical bonding, and we discussed that the mechanical bonding may be temporary, permanent or semi permanent. So, in the case of temporary, as we know, you have threaded fasteners like screw, nuts, bolts. These are the examples of mechanical bonding, that is temporary type. You will allow easy disassembling of repair, replace and adjustment, convenient for human assembly workers, but difficult for robots and automated systems. Then you have permanent or semi permanent type of mechanical bonding. So, in that you have semi permanent, you have riveting and crimping. Now, in the case of riveting, if you look at in the case of riveting also, the composition of the rivet material, that is very ductile. Basically, you have to add the two sheets using the rivets. So, the rivet can be damaged and the parent material can be taken off. So, you have that riveting is an example of that semi permanent type of welding. Then you have press or shrink fit, then snap fit. So, fitting all that type of this. So, and sewing, stitching or stapling, all these things are the examples of semi permanent type of bonding. Now, we come to the atomic bonding. So, that is your normally that is permanent type of bonding, and in that we have the solid state welding. So, as we discussed that most of the solid state welding is normally autogenous type, where there is no filler required, and here there is no liquid state formation, because here while joining you do not require any filler, as well as the material when it is joining externally it appears as to be in solid state, and at the melting point certainly something happens because of the rubbing action or because of diffusion or whatever it be, and then the joining takes place. So, the example of solid state welding is the cold welding, friction welding, hot forge welding and diffusion welding. So, in the cold welding, where that is pressure welding, explosive welding, ultrasonic welding. So, this is done at the normal temperature. So, you see that because of the pressure the joining takes place, that is pressure welding. Explosive welding, the explosion is carried out, and because of that the joining takes place. Ultrasonic welding, because of the ultrasonic ultrasonic medium that welding takes place. Similarly, friction welding, so you have the friction taking place, and because of that the mating takes place or joining takes place, so that is friction welding. Hot forge welding, where because of the high temperature and the pressure, that welding takes place where the material is still in solid state. So that is why you call it as the solid state welding. And similarly, diffusion welding, where the diffusion occurs at a state of temperature and pressure, the diffusion goes to a higher level, and then because of diffusion the bonding takes place. So these are the examples of solid state welding. Coming to the liquid state or fusion welding. Now, in the case of liquid state or fusion welding, the different kinds of the classification may be based on different kinds of fuels used. So what is the source of energy which is used for doing this operation? So for that there may be electrical means, and when we go for electrical means there may be different processes, and in the case of electricity, when we use electricity as the source of energy, then there may be welding using the formation of arc, or using the resistance welding technique, or using the induction welding technique. So on that basis you have different kinds of welding processes. So again, so this using the arc welding process, so in this case the arc is produced. So you will have the electrodes, and there will be electrodes, you have 2 electrodes, or you may have a single electrode, and thus sometimes either the workpiece can work as second electrode, or many a times the arc can be produced by using 2 electrodes only. So that way the arc is produced. Now as we discussed that the arc can be produced by using the 2 electrodes, either the 2 electrodes are used for making the arc, or electrode used is one and the workpiece works as another electrode. Now so on that basis you have consumable and non-consumable electrode. Now consumable electrode means that the electrode is consumed as the welding process carries on. So in that case, as you move, after some time you have to use the another electrode. So in these cases you have one electrode which is used, another electrode is yours, the workpiece works as another electrode, and then you go on producing the arc between the electrode and the workpiece, and this electrode goes on goes on getting consumed as the welding process is carried forward. And so that is why you have to press like this, and then after some time you have to further change the electrode. So that is consumable electrode. And in the case of consumable electrode, as we discussed when we discussed about the homogeneous type of welding operation, so in that case you must ensure that the electrode composition is same as that of the parent material. So that way you use this a consumable electrode welding practice. Now in that you have manual or shielded metal arc welding process, that is known as MMAW or SMAW. Then you have gas metal arc welding, that is GMAW. So basically what we need to see is that there must be this pool needs to be shielded against the atmospheric attack, because the weld pool, if it is exposed, there may be gaseous pickup from the environment. So we try to ensure that there is protection of the weld pool from the atmosphere. So for that you need to have a shielding atmosphere. So that is done by some means. Now in the case you may have you may have the mechanism on the electrode itself, so that you create one atmosphere so that it is saved, the weld pool is saved. You may use separate gas, inert gases, so that the the pool, the inert atmosphere is maintained, and in that atmosphere the welding is carried out. So, that is based on that you have gas metal arc welding. Similarly, you have flux coated arc welding and you have submerged arc welding. So, this way you have the different kinds of consumable electrodes welding, where the electrode is getting consumed slowly, and then you have the welding taking place. Similarly, you have the non-consumable electrodes. Now, non-consumable electrode means the electrode does not get consumed, it is only used for the production of arc, the sustenance of arc. So, the two electrodes, one is cathode and one is anode, they are used for the production of arc. This arc strikes at the appropriate position where the welding has to be carried out, and then that has to move in the fashion it is desired. So, in that case basically you are only looking for the electrodes which should be efficient in producing the arc. So, on that, in that category you have different types of processes, where that is gas tungsten arc welding or tungsten inert gas welding, that is TIG. So, here basically tungsten is used as electrode, and you have the inert gas which is used as a medium for protecting that weld pool from contamination. Then you have plasma arc welding, stud welding. These are the examples of these non-consumable electrode type of welding process. Further, we also use that electrical means or electrical medium as a source of energy for the resistance welding operations, where you have the use of resistance is applied for creating the bond between two sheets or so, mostly in the case of automotive applications. So, you have resistance spot welding or resistance seam welding. So, normally in the case of automobiles you have sheets of automobiles, and at the points if you have to do the spotting, so you have two electrodes coming from opposite end and you have the sheet. So, they will be touching at the point, the spot, and because of the resistance the heat is generated, and then there the joining takes place. So, this way using that resistance the welding takes place either on a spot or on a seam. So, that way this is known as resistance spot welding or the resistance seam welding. Similarly, you have resistance projection welding. So, this is that kind of welding practices where this resistance is used. Resistance is basically used, between resistance between that medium. Then there may be induction welding also. So, similarly resistance, then you have the induction also, induction effect of the current. Then further you have the chemical energy is used for the welding. So, in that basically the fuels which have the chemical energy stored, they are used for creating a flame, and that flame has higher temperature, and that flame basically melts the point or the spot and does the joining process. So, in that you have oxyacetylene welding, pressure gas welding, thermit welding. Here the concept is that you have a chemical energy. So, basically you are having the combination of as a gases or any mixture, and then they are basically ignited, and then by that you are getting the higher temperature, and because of that higher temperature the localized fusion takes place wherever you are trying to direct it or wherever that mixture is placed in case of thermit welding, and then the welding takes place. So, based on chemical means also welding has to take place. Then now we discuss about the solid or liquid state welding. So, in the case for the atomic bonding, now solid liquid state, in that basically what happens, earlier we have studied about solid state where everything is in solid state. Then you have liquid state where the parent metal as well as the filler metal in that weld pool zone all is converted into liquid, and then they are further solidifying to solid state. But then solid liquid state refers to that kind of welding process where the parent metal will be in solid state and the filler material which are used for joining them, they are in liquid state. So, by that the joining takes place. Now, in that we use the typical type of alloys which are low melting point alloys normally. So, based on that temperature of melting, like if the melting point of filler material is more than 450, then we call it, so we have in the case of brazing, the melting point of filler material is more than 450 degrees centigrade. So, filler material is normally copper zinc or copper silver type of alloys which is used for brazing. So, wherever somewhat more strength is required, you go for brazing. Then soldering, in that case of soldering, the melting point of filler material will be less than 450 degrees centigrade. So, normally tin lead alloys are this kind of alloys which are used for soldering applications. So, that is soldering. Then you have adhesive bonding also. So, adhesive bonding you have to many a times you are required to join. So, two components mostly in the case of automobile brakes or so. Now, in the case you use the adhesives to join two components. Now, in that you have thermoplastic adhesives which are in liquid state at that time, they are applied and then joining takes place. So, certainly there will be some limitation to up to what temperature it can withstand, and based on that you will have either thermosetting or thermoplastic. So, thermosetting certainly will be more stronger and capable, and thermoplastics will be certainly naturally it is softer. So, it will be little bit less hard. So, that way you have the atomic bonding carried out. Now, various advanced joining or fabrication processes. So, these are the conventional welding processes which occur, and we have different basis of classification by which we can say that this is how the welding process is carried out. Now, there are advanced joining or fabrication process which are used for the advanced applications or where the conventional operations are not suitable to carry out the experiment. So, also when we go for the fusion welding, then there are certainly some undesirable effects on the structure because of the large amount of heat which is accumulated at a point, and then it moves, and then the material transfers this heat through it, and certainly some part of material is affected because of that heat. So, there will be a heat affected zone where the structure is likely to change, and it changes. So, many a times we feel that zone should be normally smaller, or it should not be wider. So, in those cases we feel that we must have, or in many cases we need typical type of application of joining where the normal conventional operations cannot be done, or we may have the joining of dissimilar materials or joining of larger thicker plates, or in many situations the conventional welding operations cannot be suitable. So, we have the advanced joining or fabrication processes. So, like you have electron beam welding or laser beam welding. Now, these are basically when we have to join to a very thin point. Now, that is not possible by normal welding process. So, that can be done by electron beam welding, laser beam welding, or maybe sometimes for extremely hard materials or extremely high melting point materials. So, on those cases wherever the conventional welding operation is not suitable, we go for such kind of unique welding processes. Similarly, you have the different welding processes for plastics, like you have spin welding, vibration welding, friction stir welding. When friction stir welding is also used for the metals also, Then you have the hot plate welding, hot gas welding, implant welding, infrared welding or microwave welding. These are now, so most of the welding processes which we discussed in the right hand side for plastics, they are also used for materials, metals also. So there is a lot of research going on, and people work towards the situations so that the weldability is better for materials. You can weld or join the material with least of the difficulties and with best of the properties you can achieve by these welding processes. So that is how you can define the different kinds of welding processes, and in the coming lectures we will discuss about the different effects of welding process, the thermal effects of welding processes. Then we will discuss about different types of welding processes and its characteristics which are required to study these processes. Thank you very much.